Assalamualaikum and a very good day to Dr. Azamuddin bin Hussein. Our group will be present ultrasonic pulse velocity that will be handled at Pusat Islam UiTM Sri Iskandar. Before we start, I would like to present my team members. My name is Nur Farhada and I will present statement of case and conclusion and recommendation, while my friends Ahmad Afham will present synthesis of failure and Muhammad Amirul Hakim will present symptomatic investigative, and lastly Azwin Khadijah will be present synthesis of failure. The following are the objectives of the case study. First, to analyze the problem and issue of cracking at Pusat Islam UiTM Sri Iskandar's hallway. Two is interrogate laboratory testing to determine the main reason for the failure. 3, to ensure that the test method that has been selected is appropriate for the case study problem. Now we move to scope of study. The goal of this paper is to learn from an area a building had a construction disaster, analyze and defect, determine the cause of the failure, and suggest solution and strategies to prevent a solution like this from happening again in the future. Pusat Islam UiTM Sri Iskandar that shown in this figure is a place for UiTM Sri Iskandar student and staff to pray and do various kind of activities. It was located at University Teknologi Mara Perak, Lebuh Ipoh Lumut 32610, Bandar Baru Sri Iskandar, Perak, Malaysia. Pusat Islam UiTM Sri Iskandar was established on April 16, 2008, and the construction of the area under consideration was completed on October 20, 2010 by civils through Perunding ID Sendirian Berhad. The design and architecture of Pusat Islam are inspired by Masjid Negara Malaysia. The Pusat Islam UiTM Sri Iskandar building is a 3-story structure and its level corresponds to the ground floor, the first floor, and the second floor. This structure is more than simply a mosque. It also has various facilities on each of its level. The Pusat Islam building is combined with Dewan Ibnu Al-Khatib, which is Dia UiTM Perak, which means Pusat Islam and Dia are in the same building as shown in this picture. The area that has been chosen is the hallway area because in that area there are very critical cracks, especially at the floor and column area. There are 2 organization stakeholders that involved in Pusat Islam UiTM Sri Iskandar, which is first Organization Chart, Islamic Affairs Units, and Police Officer. These are the people in charge at Pusat Islam UiTM Sri Iskandar and people who work at Pusat Islam UiTM Sri Iskandar. These people handle all the activities that take place in Pusat Islam, such as religious knowledge lectures and others.
Alright, now we go through to the testing method. Testing method that we use for this case study is the UPV test. Alright, the UPV measurement instrument included a total of 4 parts, which is a calibration rod, 2 transducers, a pulse receiver unit, and a compult, or we can replace it with grease. In accordance with the specification, the UPV of the first wave to arrive, which is the longitude wave, is figured out using a certain wave path. Transducers that have a frequency range that span between 20 to 100 kHz and a central frequency of 54 kHz are commonly utilized in this case study. After affixing 2 transducers to the top surface of concrete, one then measures the amount of time it takes for longitude wave to travel between the transducers as well as the speed at which they travel. Alright, for the testing procedure, the concrete surface that is going to be tested firstly need to be set, and then it needs to be clean, free of dust and dirt, dry, flat, and free from any loose particles. On the concrete surface that needs to be tested, mark the testing point along the crack line with 2 different distances at each point. The work of measuring and marking will be repeated using the same procedure and measurement at the location 2 at the study areas. This will be done so that the result may be compared. The distance between each point has been determined to be 100 mm as shown in the figure. The UPV 0 should be reset using the calibration rod on a frequent basis, and especially after making adjustment to the transducer frequency or swapping out the cables. The calibration rod is labeled with the target calibration value of 25.4 meter per second. To improve the transmission of ultrasonic wave, a coupling or grease agent must be applied to the transducers and placed between the transducers and the calibration rod. The transducers are calibrated by mounting them on the rod. When placing transducers on the calibration rod, ensure that the flat side of the transducers are touching the rod. Check that the 25.4 meter per second shown on the calibration rod correspondent to the display on the pulse receiver's device. Grease was used as a coupling medium between the ultrasonic transducers and the concrete surface, so that the ultrasonic transducers can more effectively penetrate the concrete. The ultrasonic transducers need to have flat surface touching the concrete surface at each test location. Run the pulse receiver's unit analyzer and fine-tune its parameters. Record the readings at each location. Measurement should be taken using the pulse receiver unit. Testing work will be carried out at each point that has been marked during the marking work. The same procedure will be repeated in location 2 to get a more in-depth analysis. The data shown on the pulse receiver unit will be recorded in table form before analysis. The result obtained from UPV testing at 2 location concrete surface are recorded in the form of a table by obtaining readings at point A, point B and the average of both reading. As can be seen in the figure, the thickness of the concrete slab that was carried out UPV test is 350 mm thick, and the deepest crack found at testing location 1 is 317 mm deep, which has exceeded 3/4 of the thickness of the slab. This shown that the crack that occurred has exceeded the level of the reinforcement position in the middle of the concrete slab. The second highest crack depth is at point 1, which is 208 mm deep, and followed by point 3, which is 92 mm deep. While at location 2 concrete slab, we can see that the depth of the crack which is not as bad as location 1. The deepest crack at location 2 is at point 2, which is 141 mm height, followed by point 1, which is 52 mm deep, and point 3, which is 12 mm deep. In both of these data, it can be analyzed that the crack in the concrete slab is a bad condition, and repair and maintenance work should be carried out to prevent the problem from getting worse and ultimately endangering the users of the buildings.
So now we go to the description of finding to evaluate structural failure analysis. These involve multiple methodologies, which is visual inspection, structural analysis, material testing, non-destructive testing NDT, structural health, monitoring SHM, historical data and maintenance record, expert opinion and peer review, failure analysis and forensic investigation that can be used to assess the structural failure. The Pusat Islam UITM Sri Iskandar pedestrian section case study use few assess methodologies. This is because our group find the damage and structural failure. Thus, structural failure analysis only require visual inspection, structural analysis, NDT, failure analysis, and forensic investigation. Therefore, we present a causal analysis through fault tree analysis to identify the real cause of the event that occurred. For the main analysis, we set soil sedimentation or soil settlement as the main factor. Then we divide into 3 aspects that may contribute to the structural failure, which is the design aspect, where if inadequate structural design is the cause, it will contribute to structural cracking as the main cause. Apart from that aspect of construction that we don't have enough information about, given that the Pusat Islam construction project was completed in 2010, we can expect that throughout the operation period of this building, supervision, which is monitoring and maintenance activity that are relatively less emphasized, that will causing this problem to be unavoidable from cracking. And last but not least, through environmental aspect, where climate change is the cause of soil movement due to extreme weather. Design aspect, site assessment can reduce risk during site selection. Commercial construction managers, architects and engineers must examine constructability and establish the safest and most cost-effective layout. Construction and engineering professionals find it harder to learn from their mistakes, notably in preventing, recognizing and correcting design defect. A structure fails when it can't do the job. Performance failure refers to a decrease in function below an acceptable limit, while physical structure failures occur in the loss of certain features in terms of size, material and thickness. With adequate design is important to focus on. For construction aspect, building structural failure must be assessed based on construction. A large construction project requires planning, risk management, organizing, cost management, scheduling and effective strategy. Lack of inspection owing to structure craftsmanship, material and other factors might lead to construction project failure. This building also has poor monitoring, delayed preventive actions. Due to the exposed rebar surface, crack might spread and the concrete may fall off. And the last one, environment aspect. Construction has a major impact on the environment, both good and bad. Construction can cause climate change, resource depletion and habitat degradation. However, the sector is becoming more aware of the needs for sustainable practice that reduce environmental impact. This case study demands a careful review of preventive steps to avoid more serious structural breakdown. Therefore, preservation and conservation must be set aside. We include a video where we can see it's due to the occurrence of soil deposition that can be seen through uneven pebble or paving stones as showing in the video. So with that, I leave this presentation to Azun Khadija. Thank you.
Due to many flaws and column cracks in Pusat Islam hallway that was chosen as a case study location, ultrasonic pulse velocity was chosen for this non-destructive testing. Figure below shows settling concrete cracks indicating soil settling. Certain concrete crack can occur when a void is developed below the concrete surface. This can happen when a large tree is removed from the site and its root begin to root, or when the utility company digs a trench for the pipeline and doesn't compact the soil when refilling it. The foundation type and soil slope under the building may also cause failure, as in this case study. Foundation used to support Pusat Islam pipe foundation are shallow, but ground condition can make them deep. Pipe foundation are spread foundation construct of rectangular, square, or circular concrete pad that sustain localized single point, loose, light structural column or frame structures. Figure below show that Pusat Islam has 15 pad foundation points, 7 in section AA and 8 in section BB. However, in this case study area, red highlighted area, where the plan no show the pad foundation. For this case study area, the rough foundation is used in the area. Rough foundation is a thick concrete slab sitting on a board concrete of soil reinforced with steel, supporting column or wall and transferring load from structure to the soil. Because of this instability shifting soil and high water table area, the foundation is not supported by separate footing. The case study's rough foundation produce cracks. Pusat Islam is built on a hill with a steep soil slope, causing slope instability and soil settlement. While slits and stone flow downhill, slope instability and mass movement can be affected. Development near the base of steep slope may cause slope instability problem. Downslope movement natural, although it can be hastened by undermining the slope base, clearing vegetation, or redirecting natural drainage. Slope instability can cause fractures and infrastructural damage. Soil surface due to downslope movement settlement is the downward movement of soil produced by a wedge that increases vertically effective tension. As a result, vertical strain in the soil increase and earth sink. Most buildings settle over time, usually during the first 5 years. A site ground force increase force water pressure and weakly compact soil usually cause soil settlement. Change in soil moisture content such as saturated cohesive soil relaxing or drier cohesive soil shrinking can also induce soil settling. Soil settlement can cause settling concrete cracks, cracking of the foundation wall and slab, tightening of structural components such as the stair, bulking wall, change in relative position and more.
In conclusion, Pusat Islam has been selected as the case study location, and the hallway area was selected due to the crack occurring on the floor and column area. Ultrasonic pulse velocity has been selected. This testing method has been selected because it is suitable for the case study problem. This method can be used for quality control and the assessment of structural integrity. It can help identify void, crack, and other defects that may compromise the durability and safety of concrete structure. To analyze structural failure, it involves visual inspection, structural analysis, non-distribute testing, NDT, failure analysis, and forensic investigation. This result contributes to a comprehensive understanding of structural condition and possible cause of failure. The design of the Pusat Islam is a building structure that is basically built on an uneven contour surface. The Pusat Islam building maintenance is still lacking in many areas. To address ground settling at the floor and column, here are some suggested improvement and recommendation. First, foundation repair. If the settling has caused damage to the foundation, it is important to address those issues properly. Repair methods may include underpinning, which involves strengthening the foundation by adding additional support beneath the existing footing to transfer the load to more stable soil layers. 2. Regular monitoring. Establish a monitoring program to track any ongoing settling or changes in the foundation. This can help defect issue early on to allow for timely intervention. And the third is foundation assessment. Conduct a true assessment of the foundation to identify the extent of cause of ground settling. This may involve consulting with a structural engineer and geotechnical expert to evaluate the soil condition, drainage pattern, and any potential source of instability.